So once again, the materials for our practical class include nitrosol, SLS, caustic soda, soda ash, sulfonic acid, not sulfuric acid, texapon, foam booster. This is a foaming agent, foam booster. This is our perfume, our color, preservative in our bowl. So other materials include a mixing bowl and wooden spatula. This is a bucket for taking water, and the other blue bucket for measuring volume of liquid. So first we are measuring 10 liters of water. This bucket is calibrated on the inside. You can see the child, students of Children's Academy Montessori, measuring 10 liters of water all by herself. So she's going to do this now because we want to dissolve the first chemical, nitrosol. Take note that nitrosol is a thickening agent. This is what is responsible for the thickening of soap. If you notice, liquid soap is a bit thick. It's not exactly watery like fruit juice. So this nitrosol makes it thick. Now after pouring this in, you stir with your wooden spatula so that the particles can dissolve very well. You don't want to have soap that has particles. Yes, soaps are usually very clear, liquid soaps, clear and beautiful. So stirring helps to dissolve the particles properly. So you stir very well. The stirring is still going on. Alright. And then the next thing, after stirring, you transfer the nitrosol and water mixture into the mixing bowl. You see the mixing bowl is bigger than the measuring bucket because we'll be using that measuring bucket to measure volume for other chemicals. So now this is SLS. We are going to dissolve SLS in 2 liters. There's already 2 liters of water in this bucket earlier measured. Now we are dissolving SLS in these 2 liters. SLS is a foaming agent. As you can see, as we stir, it's already beginning to foam, right? So it's a foaming agent. It's one of the foaming agents for making soap. SLS, sodium lauryl sulfate. Now that we are done, we are transferring the SLS and water to the initial mixing bowl where we have nitrosol. So we'll call this big bowl A. To avoid repetition, just say bowl A. So now this bowl A has water, nitrosol and SLS, right? Okay, that's good. Move on. I hope you are following the class. You are watching. You can see your fellow students stirring. This is done by students, handmade practical on soap making. We stir very well. Stir very well. Now next we'll be dissolving caustic soda. So this is caustic soda. We dissolve this. This is a base. Remember we said I taught you in class that soap is made from the reaction between an acid and the base. So that's the base. We are dissolving it in another 2 liters of water already prepared in this bucket. So now we pour the caustic soda in, and as usual we stir. We always stir. In fact, stirring is even the main job in this soap making. You have to stir completely so that the particles can dissolve. Okay, and then you can have a fine soap. So we keep stirring. Remember, the bucket was used for SLS. This is the same bucket we are using to measure all the chemicals. So there's bound to be this foaming agent in it. So now we are transferring the content to the bowl A. Now in bowl A we have nitrosol, SLS and caustic soda. Beautiful. We are going to go on. What's the next thing we are going to mix? The next chemical we are going to mix, we'll find out. Okay, you can see the stirring is still going on. Stirring is very important. Very, very important. Right? Very important. So the next chemicals we'll be mixing will be Texapon and sulfonic acid. We'll get there, you see. But first, let us stir very well. So this is sulfonic acid. This is the color of sulfonic acid. It's black, just like honey. It's viscous, and that is Texapon in a nylon bag. So in 2 liters of water already measured in this bucket again, we are pouring in the sulfonic acid. You can see sulfonic acid inside the water. It's just like a black liquid. And then the Texapon is like a gel. It's jelly like. You can see it. That's Texapon. Texapon is also a foaming agent. A what? Foaming agent. So we are mixing Texapon, sulfonic acid and water, and as usual we are stirring. So you stir, stir and stir like we are doing right now. You will enjoy stirring anyway, not like stirring is a big deal here. So just keep stirring so we can have the particles well dissolved. Now we are transferring the water, sulfonic acid and Texapon to bowl A. Right, just keep transferring to that bowl A. Our bowl is getting full. We should have used a bigger bowl, right? So take note. These are some of the things you observe, so in subsequent times when you are making your soap, you know just what to do to make your soap come out finer. We might have to share this content into 2 bowls like we did in class during this practical. So next is the soda ash. We are going to dissolve soda ash now in water. You see the child there stirring bowl A while I dissolve the soda ash in water. Remember, another 2 liters of water, right? So soda ash in another 2 liters of water, and as usual I do what? I stir. We keep stirring, we don't get tired of stirring. So that's soda ash in water. We've mixed nitrocell, SLS, caustic soda. Now we have done Texapon and sulfonic acid. Now we are adding soda ash. 5 chemicals already mixed, or rather is it 6 chemicals? If you are counting, just count well. So that is all we have done. You can see a proper stirring. We are stirring all these contents so they can mix up together for a chemical reaction to take place. Yeah, soap is actually wasting. Like I said, the bowl isn't big enough, so you can see it pouring now, but not bad. Do you know what we're adding now? Perfume. And for this class we bought lemon perfume. You know that sweet smell of citrus fruits? Yes, we bought lemon perfume and it smelled really good. So this is lemon perfume. We'll stir in so that I can go around the soap mixture. And then this is the foam booster. We are adding a foam booster to make the soap foam. You know, soap is a cleansing agent, so it's very important that it foams. Not that you now make a soap that does not foam. That one is not good at all. So you add the foam booster, and what do you do again? You stir. If you noticed, the perfume and foam booster were not added to any liter of water. It was added directly to the mixture of soap. You don't need to dilute it somewhere before adding, right? Okay, so now we are adding the color. You see the color in the nylon looks orange or red, but when you stir it in water, you find that it has a different color. Let's find out what color it has. Color what? This is color green. Color green, right? And if you further pour it into the bowl A, you find out that it's not just green but lemon color. Let's find out now. See, it's lemon green. A beautiful color for a beautiful, good smelling soap. So this is color. We're adding color to the soap mixture. If you notice, the content of soap in bowl A has reduced because we have divided the content of this soap into two containers to avoid wastage. So we are stirring in hard and good. Now we are adding the preservative. The name of this preservative is formalin, and the reason we are using a preservative is to keep the soap from spoilage. You might want to store the soap in your house, so that is why we need a preservative so that the soap does not spoil. And of course, this is our soap, the final product of our practical. I hope you enjoyed the class. from me to you is a goodbye.